We will continue our meeting. Next report. Darina Kapusta, Sergei Kriptsov, and Dmitro Chimochenko holds linear model of COVID-19 morbidity forecasting in Ukraine. Are you ready, Dr.
Yes, can you hear me? Because I think I have some problems with connection.
We can hear you.
Okay.
And now you can see my screen, yes?
Good.
Okay, so I'm hello, and I'm glad to present you our research, holds linear model on COVID-19 morbidity forecasting in Ukraine. This is a small part of our big research on investigation of COVID-19 epidemic processes, which is made by us and National Airspace University Kharkiv Aviation Institute. So in 21st century, oh sorry, something wrong. Just a second, have a problem with my presentation. Sorry. Just a second. So while I'm trying to fix my presentation, I want to tell that we have a big project on COVID-19, which is financed by National Foundation of Ukraine. And we are using a lot of methods there. Some of them are methods of machine learning, and one of them is whole linear model, which I'm ready to tell you about. In the 21st century, infectious diseases still remain significant threat to humanity. From an evolutionary point of view, the emergence and persistence of pathogens of infectious diseases is inevitable, and any cellular form of life, including humans, is a target for parasitic microorganisms. In response to bacterial or viral threats, eukaryotic and prokaryotic organisms have developed defense mechanism to counteract pathogenic infectious diseases, while the latter in turn reacted by developing counter-protection mechanisms to overcome host defense systems. This constant evolutionary arms race continues today, and therefore unpredictable outbreaks of infectious diseases remain a constant challenge for humanity. The outbreak of coronavirus infection is the largest recent challenge for health systems, and the rapid spread of the disease around the world is due to many factors. Globalization plays a key role in the process. So in members and other countries outside China, the first confirmed case was reported on March the 3rd, 2020. And the COVID-19 pandemic in Ukraine is characterized by territorial unevenness, which is associated with different population densities, differences in communication, religious traditions, uneven migration flow, regional characteristics of the fight against COVID-19, and so on. At the beginning of the pandemic, an increase in incidence was observed in the Western regions, and the COVID-19 pandemic is an unpredictable threat to public health, the national economy, and social development that can have uncontrollable consequences and cascading consequences for all aspects of society. To successfully cope with the threat that has arisen, to reduce the impact on health systems and the economies of countries, to overcome the unforeseen consequences of public health measures taken to combat the COVID-19 pandemic. It's necessary to respond in a timely manner to the changing epidemic situation by introducing effective, scientifically based, adequate, the current situation rational measures. So the aim of the study is to develop a linear hold model for predicting the incidence of COVID-19 in Ukraine and to assess the possibility of its use. The epidemic process is the only form of existence of infectious diseases, a living organism of a person or animal that is the natural habitat of the pathogen, where the pathogen lives, multiplies and is released in one way or another into the environment, has named the source of the causative agent of the infection, and the way the pathogen changes from one host to another, the mechanism of transmission of the pathogen. When the mechanism of transmission of the pathogen from the organism or the source of infection is implemented, it enters the cell organism in which the pathogen applies, accumulates, and begins to be released into the environment, turning into a source of infection. The epidemic process ensures the continuity of successive generations of the pathogen with a constant change of hosts and its preservation as a biological species. So the category epidemic process makes it possible to clearly understand the principles of the disease in society, provides a tool for understanding the concept of elimination of infections, and outlines ways to combat infectious disease. Exponential smoothing is a method for smoothing time series, the computational procedure of which includes the iteration, taking into account the aging of information as it moves away from the forecast period. In other words, the older the observations, the less it should influence the value of the forecast estimate. The idea behind exponential smoothing is that as we age, corresponding observations are given decreasing weights. This forecasting method is considered to be quite effective and reliable. The main advantage of the methods is the ability to take into account the weights of the initial information, the simplicity of computational operations, and the flexibility of describing various dynamics of processes. The exponential smoothing method makes it possible to obtain an estimate of the trend parameters at last observation. The method has found the greatest application for the implementation of medium-term forecasts, and for the exponential smoothing method, the main point is the choice of the smoothing parameter and initial conditions. Identifying and analyzing the trend of a time series is often done by flattering or smoothing it. Exponential smoothing is one of the simplest and the most common techniques for aligning the input of which sequentially receives the members of the original series, and the output forms the current values of the exponential average. So let X is a time series. Exponential smoothing of the series is carried out to the next recurrent formula. The smaller alpha, the more filtered and suppress the oscillations of the original row and noise. If you consistently use the recurrent relationship, then the exponential average ST can be expressed through the values of the time series X. If earlier data exists by the time smoothing start, then the arithmetic average of all available data or some part of it can be used as an initial value S. So simple exponential smoothing of time series containing trend leads to a systematic error associated with the lack of the smoothed values from the actual level of the time series. To take into account the trend is in non-stationary series, a special two parameters linear exponential smoothing is used. Unlike simple exponential smoothing with one smoothing constant, this procedure smooths both random distributions and trend using two different constants. It consists of three equations. The first is the data smoothing equation, the second is trend smoothing equation, and the last is forecast equation for the period T. So for the experiments, data on the COVID-19 new cases provided by the Center of Public Health of the Ministry of Health of Ukraine. The host model for predicting incidence of COVID-19 was implemented as a software product in Polytechnic, which automatically loaded from the Johns Hopkins University data on Ukraine provided by the Center for Public Health of Ministry of Health of Ukraine. The results of COVID-19 morbidity in Ukraine using that model is shown on the slide. The results of forecasting of incidence for 10, 20, and 30 days shows that short-term forecasting for 10 days is the most accurate. Nevertheless, for use in practice, we can also use the result for 20 days. Since such a forecast shows what will happen to the population after the 14-day incubation period. This work is a result of the analysis of various models and methods for predicting machine learning in order to predict the incidence rate and compare the results of calculation of each of the models. The whole methods was studied. As part of the study, a linear Holt model was developed, and the quality of the models was shown in the form of the size of forecast error, and the graph was built on which we can clearly see the calculation of predicted incidence for COVID-19 for 10, 20, and 30 days. So we can use the 10 days forecast is more accurate, but as I said, we can use 20 days forecast to investigate the situation after the 14-day incubation period. Thank you for your attention. And as I said, this is a small part of our project. If you're interested in other methods and the whole model, you can look it on our research gate. Thank you for your attention.
Thank you very much. Thank you very much.
Can you ask a question?
Questions?
Yes,
Can I ask a question?
Please. Dr. Ovetsky.
Well, thank you for your report. You are harnessing an auto-regression model, but didn't you think about using neural networks and to compare results?
Yes, we actually have a model with a neural network. And actually, as I said, this is a small part because we investigated like 7 or 8 machine learning methods for forecasting of COVID-19. Also, we have a neural network model, and we have an agent-based model, and actually that machine learning models and also a neural network model we use only to calibrate our agent-based model, because machine learning models allows only to calculate forecast. It's enough, it has enough accuracy, but it's not possible to investigate the factors which are influencing the dynamics of epidemic process. So we are actually using some ensemble models which consist of agent-based model and machine learning model.
Thank you.
Thank you very much. Some other questions? No question. Thank you.
Thank you.
For your speech, and we are asking for next reporter. Natalia Shakhovska, Władysław Sokolowski. Anybody from these participants? No. Today, Yevchenko present, not present. Then next, not present. Okay, next. В'ячеслав Репета, Ігор Мішка, Валерій Жидецький, Валентина Слободянюк, Володимир Пилипюк. Миклушка. Окей. Please.
Igor Miklushka. Dear colleagues, dear day, I represented the Ukrainian Academy of Print.
On the process of digital inkjet printing of photographic images. Yes.
Yes. Good day, dear colleagues. I represented the Ukrainian Academy of
Microphone. Okay.
Just a moment.
Screen.
May I start?
Yes.
Just a moment. I must to share screen. Just a moment. Our article about a model of the influence factors on the process of digital inkjet printing of the photographic images. The article presents the results of the study of the factors influence on the printing process of a photo image, including the possible deformation of photo paper. The main factors influencing the printing process quality are established. The oriented graph of the influence and the dependencies of this factor is constructed. The analysis of the patterns of leaders in the development of digital ink technologies has shown that such media photo papers are multi-layer systems. They have one or two recording layers. A cellulose base protected by polymer coating in most cases. The great the need to absorb water during printing is. The great the thickness of the multi-layers paper recording system is formed in the photo paper production process. According to the photopaper optical image density and minimum paper are achieved with such coating. If the inkjet printing process is considered, it primarily depends on such factors as the printing resolution, the capabilities of the photo printer and its printing heads. There are guidelines for selecting the photo paper depending on the printing resolution, because many, the more water it will absorb. Another factor that affects the photo paper deformation during printing is the image filling area. So, this presentation is devoted to construction models to establish the factor priority and determine their optimal parameters for the inkjet printing process of photographs by using the fuzzy logic tools. The first stage of our study, the correlation by ranking method. The set of factors the selected factors are denoted by mnemonic names for clarity, such as photo paper weight, print resolution, surface. On a figure 1, we will see oriented graph of factor of the inkjet printing process. There are direct and indirect influence and the integral dependency on all the factors is as follows. For our orienting graph, the following conditions are set. On a figure 2, we will see number of the influence and dependencies of factor. Figure 3 presented the direct and indirect influence of factors of the process. Table 1, including the calculated data of figure 4, represented multi-level model of factor influence on the photo inkjet printing quality. Structure of the model of factors influence on the basis of fuzzy logic we will see in table 2. Next slide presents a fuzzy knowledge base is formed on the selected quality parameters of the inkjet printing process. Are formed to ensure the images, then substituting the degrees of belonging to the system of fuzzy logic equations, one of the options for calculating the quality of the print of a photo image obtained. The figure 6, we will see a model of influence of the factors on quality inkjet printing processes. As a result of the simulation processes of the influence of the priority factors implemented using fuzzy logic, a matrix of the knowledge of fuzzy logic equations are formed to calculate the membership functions of the linguistic variables with the corresponding given terms. Analysis using the if-then condition and the defuzzification operation has allowed obtaining a quantitative assessment of the quality of the inkjet printing processes.
Thank you very much.
Thank you for attention.
Quite pure quality of this video. Sorry, maybe somebody want to ask question to speaker. No questions. Okay. Thank you very much again.
Thank you so much.
We inviting next reporter, Andriy Krysovati. Христина Лип'яніна, Гончаренко, Світлана Саченко. Economic crime detection using support vector machine classification.
Hello, everyone.
Hello.
One moment.
Share screen, please.
Yes.
Okay, we see.
Hello, everyone. My name is Kristina Lipyanina Honcharenko, and I would like to present my paper on economic crime detection using support vector machine classification. A fiction enterprise in Ukraine should be considered as an entity that is regressor in a violation of the regression rules because of the constituted documents are not complete to current regulation. Activities are contrary to law or the constitutes documents. Violation of tax accounts and reporting violation of the introduce of the enterprise organization form, violation of the introduce of about ownership and location. However, the interest of an economic crime often takes a lot of time for law enforcement officers. In this regard, the development of a method of detection, a fiction enterprise based on support vector machine classification, is one of the most promising areas for detection economic crimes. It should be noted that the existing works do not describe the detection of fiction enterprise with the help of information technology. A goal of this paper is to develop a method for detection, a fiction enterprise based on support structure of the proposed method is shown is slide 2. As the first stage, block 1, the user submits a request to identify a fictional enterprise. To build a method based on support vector machine classification is necessary to obtain a set of data for forming the algorithm support vector machine classification. The required data are entered in block 2 directly by the user into the system. Company code, legal address, physical address, names of manager, maybe several photos of equipment with geolocation. All the parameters can be supplemented with a new one and general the exist one. The algorithm is usually adapted. Based on the data entered by the user to analyze the parameters, block 3, and to search for approach values from source of information created using the approach API and photo processing method of pattern recording, which is the purpose of future research. Next, composite of data, block 4, with each other, namely FR with photo is made. Then all the data is transformed to the storage database, block 5, and converted in binary values, block 6. The block 7 shows the value relation review to whether the company is fiction or not. One of the most important steps should be a distributed of data, block 9, into 2 groups. Training set 50% tests and 2%. Next, and classify the data using the classification method of machine learning support vector machine, block 11, and evolution the updated model, block 12. Forecast study data from 1,100 companies. The data that are present in logical binary values. There are 355 fiction enterprise in the set. The degree of dependence between the indicator with the definite of a fiction enterprise is present in the form of a correlation matrix indicate of slide. The matrix shows that the fit indicator has a low correlation with other parameters. It is difficult to determine the dependence on individual parameters of whether an enterprise in conduction economic crime or not. Therefore, it is advisable to use machine learning algorithms that will more accurately determine economic crime. To do this, they perform modeling using the method of classification method, machine learning support vector machines. Simulation of support vector machines was performed by three approaches: linear, polynomial, and radial. Other approaches also exist, but are not used much less frequently. The best regular are obtained by classification by polynomial approach. The training sample showed the evolution results at 100%. The test sample showed an estimate of 97%. The confusion matrix for training calibration shows that 158 and 612 indication of correct defined positive and negative class, respectively. Zero indicators are not defined correctly. In the test sample, the confusion matrix showed that 61 and 268 indication were determined correctly, and one indication was determined incorrectly. So that's all. Thank you for attention.
Thank you very much. Thank you very much again. Any questions to speaker? No questions. Thank you.
Thank you.
And we have only 6 minutes, but we'll ask Sergei Ripa, Anatoly Sachenko, Maria Ripa, Oksana Chereshnyuk. Anybody will talk?
Yes, my name is Taras Lindyuk.
Okay, please share screen.
Oh. Do you see my screen?
Yes.
All good, please.
Yes, good.
Good. My name is Taras Lindyuk, and I present the paper Neurogenetic Tool for Fintech by Sergei Ripa, Anatoly Sachenko, Maria Ripa, Oksana Chereshnyuk, Oleg Sachenko, and Taras Lindyuk. Trends in the modern economy increasingly confirm that in the face of growing climatic environment and social challenges and risk, the requirements of reliability and stability of global, regional, and national financial system is the long run and can meet only by harmonizing the requirements with sustainable development. The financial system consists of institutional units, markets that interact to mobilize funds and investment and provide them, include payment system, not so much to financial business, and to refocus on the fintech and technological innovation sectors. The emergence of the category of green finance, the growing influence of renewable energy sector with appropriate financial infrastructure and their classification as drivers of civilization requirement. All these tools appeared only recently, but have already won the attention and commitments of many experts and analysts. On figure 1, the growth of crypto economy is shown. As you can see, the main indicators and ratings of the crypto economy, and we have dynamics over 1,000 of persons. On the other hand, fintech instruments work to the financial system to mobilize sources of long-term investment and as means of transferring monetary policy of real economy. On the other hand, fintech today represent the sector of technology startups whose products replace traditional financial market participants. In this context, we can identify 4 epochs of development of fintech industry from 1.0 to 3.5. In the last period of fintech 3.0 or 3.5, which corresponds to the activation and spread of crypto economy, the aggressive promotion of genetic tools in the practice of supporting fintech solution has just begun. According to the leading financial scientists, the world community today is at the stage of 4 or even on the beginning of the 5th industrial revolution, which began in 21st century due to widespread use of production of digital and information technologies, which originates during the previous revolution, namely the internet, 3D printing, bio and nanotechnology, advance in artificial intelligence, genetic engineering, space, breakout technologies, and so on. Dedicated tools of neurogenetics are becoming the dominant components of innovative technologies, IT, robotics, and fintech. The concepts of fintech today is a phenomenon along with the positive attitude of world community is also of concern, in particular from representatives of regulatory bodies. We have 4D: digitalization, disintegration, democratization, and decentralization.
The speaker, we should reconnect. We have 30 minutes, 30 seconds now.
Okay.
If you allow. Dear participants, please reconnect now.
No.
Yeah.